Hello, hello, hello. 1.3, right. Triangle, trigonometry. So let's get back to the basics. When we're talking about our right triangle, and we have an angle, theta, the side length that is across from this is labeled the opposite. The side length that is across from the 90 degrees is always hypotenuse, and the side that's right next that helps create that angle is adjacent. The only thing that changes is the opposite adjacent depending on the angle. When we're talking about our 6 trig functions in geometry, we had SOHCAHTOA to help us figure out our first 3, which is opposite over hypotenuse for sine, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. And then these, because we know that the reciprocals are going to be for our next 3, cosecant hypotenuse over opposite, secant hypotenuse over adjacent, and cotangent adjacent over opposite. So as long as you got one, you got all 6. That's always going to be the case. As long as you have one, you have all 6. So like for this first question, before we can actually even get into this, in order to figure out all 6, we do need to have 2 sides. Once we have 2 sides, we can always figure out the third side in this case, because we have this special thing about a right triangle that we have a squared plus b squared is equal to c squared. And when you solve this equation, if it is not a perfect square, in this case it will be because this is a Pythagorean triple, but if it's not a perfect square, then you need to leave your answer in the simplest square root possible. So in this case, 4 squared. That is a fun game, guys. Plus 3 squared is equal to c squared. So in this case, this becomes 25 is equal to c squared, and then we take the square root. Now, typically when we're solving for an unknown, we would have a positive negative 5 here, but because we're talking about an actual length, it's going to be just one line. And so now, since we have all 3 of our side lengths, we can figure out what our sine, cosine, tangent are. So right now, I want you to pause the video and try to figure out the sine, cosine, tangent, cosecant, secant, and cotangent. And you should have gotten our opposite over hypotenuse is 4 over 5, our adjacent over hypotenuse is 3 over 5, and our opposite over adjacent is 4/3. And again, our other 3 reciprocal functions are 5/4, 5/3, and 3/4. So let's get down to this next problem. Let's find the exact, or find the values of each one of these scenarios. This again is where you have to know your special right triangles. And in a special right triangle, if this is 45, this ratio looks like this. So now that we know what our angle is and we have our ratios, sine of 45 is going to be our opposite over our hypotenuse, which is 1 over square root 2, which again, if I rationalize that, would be square root 2 over 2. If I do cosine of 45, well, that's going to give me the same ratio of 1 over square root 2. And again, if I rationalize that, 2 over square root 2. And tangent of 45 is my opposite over my adjacent. Now, again, you should be like, I am getting so used to these numbers. These numbers are going to keep on popping up. Now, I want you to try to do example 3 by yourself. Notice how the number does change. And you should have gotten square root 3 over 2, 1/2 and 1/2. You should have noticed that these two are the same. And again, because these are complements of each other, and the opposite trig function, that will always be the case. We'll get more into that later there. Okay, next, easy peasy, lemon squeezy, using our calculator. So first, we are in degrees. So when I'm looking at this, I'm going to make sure to go to mode and make sure to set this into degree. And then I'm going to quit. Now, this is in minutes, this is in seconds. There's 2 ways that we could do this. We could turn just all into degrees, and that would look like this. Because this is degrees, here's minutes, so there's 60 minutes in one whole, and then this would be our seconds. In our seconds, there's 3,600 seconds in one whole, okay, in 1 degree. It's kind of like a clock like that. You could also, in your handy dandy calculator, there's a glare, sorry about that. You could go 1 divided by, this is where you have to know 1 divided by cosine, and then we could go 5, and look at how it has this angle measurement. So I'm going to go second apps my angle, type in the degree, and then I can just keep on typing my 40. Again, my angle measurement. This time I'm going to go to my minutes. So if you didn't know, it did not have a second key. So there's 2 options. We could either do 12 plus our 12 over 60. I didn't mean to have this right here. Or we could do 12 over 60 and then label it as minutes. I'm going to go 12 divided by 60. And I'm going to have, second insert, parentheses, to make sure that this is going to be a degree. And by the degree, I mean second, minutes. And then close my parenthesis, because notice how I had that parenthesis right there. Actually, never mind. We're not going to do it that way because we're not. If you only had the minutes, you definitely could do it that way because of the seconds. It doesn't have seconds on there. However, your calculator can change it into seconds. So now we have our 5 plus the 40 over 60, 12 over 360. Now we can do our 1 divided by, sorry about that, guys, second, cosine, second, answer. Oh, man. Enter. My answer should be, again, if you're in degrees, 1.0049 would be that ratio. So going over here, I want you to try to do this by yourself. But again, I want you to type it in as a fraction. So we have 34 plus our minutes would be over 60. And our seconds are over 3,600. So try to do that one by yourself right now, making sure that you are in degree mode. You get 1.7651. This next question. You're given an acute angle and you know that this ratio. There's multiple different ways you can do this, but we're going to use it by using our trig identities. So these are some of the trig identities that we have. One that we're going to use right now is this one right here. Sine squared plus cosine squared equals 1. That's one that you should remember. So if I know what my sine is, I know that 0.6 squared then plus whatever cosine theta squared is going to be equal to 1. So now this is just a equation that we can solve. So if I subtract off 0.6 squared, which is 0.36, that means cosine theta squared, if you want to rewrite it, it could look like this too, is equal to 0.64. And then you can take the square root of both of those. That means cosine of this theta is going to be equal to 0.8. And that right there is my final answer. So that's using the trig identity. Sine squared plus cosine squared is equal to 1. So this next one, again, we know our sine, but we're trying to find tangent. If we look back at this, well, we don't have a tangent and sine here. However, we have a tangent sine right here. So if we're looking for tangent, if we know sine, we can set up that equation. So we know that our tangent of our theta, because tangent's always going to be equal to our sine, which is 0.6, divided by cosine, which we just found, which is 0.8. So if you simplify that, then our tangent of our angle is going to be equal to 3/4 or 0.75. So example 6 is the same type of thing. You should get this out and try to look at your trig identities. And I want you to try to figure out these two, looking at the trig identities of what could help you solve for those. So you should have got cotangent is equal to 3 and secant tangent is square root of 10 over 3 because the square root of 9 is 3. So again, looking at these trig functions, this is kind of basic trig functions trying to use identities. We will be getting to much more heavy identities in the future, but trying to rewrite this so it looks like this. And again, if you took pre-calc, you know, oh, these can get much longer than what we have so far. But looking at my trig identities, again, the first thing I want to do, a lot of times the easiest is try to change everything to sine and cosine. So if I'm just looking at this, how is that equal to 1? I can rewrite sine. Cosecant, because cosecant is the same thing as 1 over sine. So if I can rewrite that as 1 over sine, then that's going to be equal to sine theta over sine theta. And look at that, that's equal to 1. So we got there. Now in this problem, I noticed that you should try to change to sine cosine first, but one thing I noticed right away, I have 2 parentheses in the conjugates. Conjugate means that one is adding, one is subtracting. So I would actually FOIL this out. When you FOIL it out right here, your 2 insides cancel each other out because they're conjugates. So now I have cosecant squared plus cotangent squared. And now if we look at that, minus cotangent squared. Now if we look at our identities, we have an identity right here that if we took cosecant and subtracted cotangent, that's equal to 1. So this right here is equal to 1. So then We got there. Again, it's just about trying to apply those identities. And the last three questions are actually applying math or trig into the problem. Whenever there's not a picture, you should always draw a picture. So I want you to read this and try to draw a picture first. So this is what your equation looks like. So if I'm looking at this, I'm looking for my opposite. I have my adjacent. So that's going to be tan of my angle, again, in degrees, is equal to my opposite over my adjacent. I want to get rid of that division. Opposite of dividing would be multiplying. So I'm going to multiply by that tan 78.3. And I can plug that now into my calculator in degree mode, making sure you're in degree mode, and you should get 555 feet. That's an angel number. Right now, I want you to try to pause the video and try to read and draw the picture for this next one. So labeling does help. Here's our path. Here's our walkway. It's 200 distance away. So now I'm looking for this angle. So this is my opposite. This is my hypotenuse. So that's going to be our sine of our angle is equal to my opposite over my hypotenuse. Well, this simplifies down to 1/2. And we know that the sine of an angle at 1/2 is equal to 30 degrees. So this would be at 30 degrees again, because our opposite 1/2, that is our special right triangle, 30, 60, 90. There you go. What you do is pause the video and figure out this last one by yourself. You should have got your C value here is 12.7 feet and your A value here is 12.0 feet. Again, two different trig functions that we're setting up there. There you have it. Bing, bada, boom. Have a great, grand, wonderful day.